Alright, hey everybody, this is Miss Paige. If you're watching these videos, it's probably because you signed up for AP Physics, and if you're not in my AP Physics class, well, welcome, and I'm going to teach you some skills you need to complete AP Physics. We're going to start the year by just learning our mathematics skills. We're going to learn how to convert units, manipulate equations. We're going to learn our trig functions, sine, cosine, and tangent, and then just go over some basic graphing skills. The way my notes are structured, I always put definitions you may need at the top. So we have variable, which, is any symbol or notation that represents a quantity. But then you could also have constants, which is also represented usually with a letter symbol. But constants are known set values that people have made. So one example would be the ideal gas law constant R, which is 0.0821 liter atmosphere mole Kelvin, which we will not use in this class. Some of y'all are probably excited about that, but there will be other constants like the gravitational constant. And then you got hypotenuse, x component, y component. So let's talk about dimensional analysis. Now on the AP exam itself, there won't be too many unit conversions that you need to complete, but you do need to be able to analyze an equation and know what units each variable has, so you could maybe fill in the blank on a missing variable. So it's really important that you know how to read variables, know how to read an equation, and also understand the units that go with variables. Some common examples would be time, which is represented with t, seconds, length, x, which is in meters, mass is given in kilograms for this class, and then temperature, which we won't be using maybe for fluids, but not typically, but temperature is measured in Kelvin. Okay, so if you do need to convert a unit, you're going to have to use the railroad track method, right, that we learned in chemistry. So step 1, start with a given quantity in units. Step 2, set up a fraction using the appropriate conversion factor you need. Step 3, the units that need to be canceled are placed diagonal across from each other, and then you're going to multiply across the top and then divide by the bottom numbers. And if you do it correctly, you'll see that the corresponding units should be diagonal from each other, one on top, one on bottom of the fraction, which does mean it goes away. Notice the numbers do not go away. There's still a 56 and a 1, but the units themselves have canceled. So once you get everything set up, like I said, the tops, you'd multiply all the top numbers, divide by all the numbers on the bottom. So for this one, we do 56 times 3 times 12, and then we divide by 1 and divide by 1, which dividing by 1 is not necessary, but you can type it into your calculator if it makes you feel better. Okay, you should end with the last unit written. So in this example, it would be inches. Inches doesn't have a counterpart diagonal from it, so it hasn't been canceled, so that would be the ending unit. So you have 2016 inches for that problem. Some common conversions you need to know. Anytime you have centi, it's 100 centi for every 1 base. So like 100 centimeters is 1 meter. And then 1,000 milli is 1 base, so 1,000 milliliter is 1 liter. And then for kilo, 1 kilo is 1,000 base units. So 1 kilogram is 1,000 grams. And those are the 3 most common ones that you need to have memorized to do conversions off the top of your head and on the AP exam. They will not give you those 3, but you may need to have them, especially the kilograms to grams. Okay, so let's look at our first problem. In this problem, we have 3.4 kilograms, so that's my given. And then it wants me to convert it to just regular base grams. So let's start off the problem just by starting with the given. So my given is I have 3.4 kilograms, and then set up your railroad track. The next thing I need to think about is what conversion factor will get me from the given to the wanted. So we just talked about 3 conversion factors you need to kind of have in your brain, and one of those was kilo. So just remember that 1 kilo, which in this case is kilograms, is 1,000 base units. So 1 kilogram is 1,000 grams. So that's our relationship. Then you just need to decide which part you're going to place on top and which part you're going to place on bottom. So looking at it, we have kilogram as my given. And if I want my diagonals to match, that means my kilogram will have to go on bottom. Sorry, that's 1 kilogram. And if I put the kilogram on bottom, that does mean that the grams has to go on top. So I'll have 1,000 grams above. And since it's matching, those kilograms do cancel. Remember, the units are not, or sorry, the numbers are not canceling, just the units. So I'm not going to cross out 3.4. And then it looks like with that, grams would be left over, and that is what I want. So I'm going to stop there. So I'm actually done. Now that I have my railroad set up, remember we do multiply the top, divide by the bottom. So I'm going to do 3.4 times 1,000. And then you can divide by 1, but you don't have to. So 3.4 times 1,000 would give me 3,400. And then, of course, we need units. We can't just leave a number by itself. So that would be 3,400 grams. Okay, let's talk about what you would do when dealing with units with a fraction, like grams per centimeter. So when you're dealing with that, you want to keep the number. So I'll keep 67.8 with the top unit. So 67.8 grams per centimeter. And so on the bottom, you have that centimeter, but that number is not going to be on the bottom. The number only gets put on the top. So that's how you set that up. We have 2 things to change here. We have grams to kilograms, which is similar to the problem before, but now we also have centimeter to meter. So we have 2 things to take care of. It does not matter which one you do first. You could do top first or bottom first, since multiplication and division are on the same order of operation. It won't matter what order you go in. But for me, since I usually take care of the top, I'm going to do the top first, and then I'll take care of the bottom. So for gram to kilogram, we have, again, 1,000 grams is a kilogram. I just have to decide what's going to go on bottom. Now this time my gram is what I start with. So to get that to cancel, I'm going to have to put the 1,000 grams on bottom. 1 kilogram would go on top this time. Okay, and again, it's diagonal, so those grams would cancel. And I am left with kilograms, which is exactly what I needed. So I am done taking care of that. I'm going to circle it so I remember that I'm finished. But I do still have this centimeter right here, so I need to fix that. So I have to think, what is centimeter to meter? Well, you could think of centuries or cents in a dollar, but a cent is 100 of something. So 1 meter is 100 centimeter. Now, it does get a little tricky thinking about how to take care of the bottom, but I just want you to remember it's always the diagonals need to match. So with centimeter being on bottom, we need centimeter to match diagonal from that. So that would be, we need the centimeter on top, 1 meter on bottom. And just like before, if it's diagonal, it will cancel. So my centimeters has gone away. That 100 is still there. But the meter has not been canceled. And I'm going to circle that because that is actually what I wanted. I want a kilogram on top, meter on bottom, and that's exactly what I have. So I know I'm finished. So I'm going to go ahead and close out the railroad track. And then to solve, we just need to, again, multiply all the tops. So I'm going to do 67.8 times 1 times 100. And then we're going to go divide by the bottom, divided by 1,000, and then divided by 1. So 1, 2. All right, so in my calculator, I'm going to type 67.8 times 1 times 100 divided by 1,000. And then again, you don't have to do the ones if you don't want to. So we get 6.78, and then the unit for that would be kilograms on top, meter on bottom, and that would be my final boxed in answer. Okay, let's try 0.89 hours into seconds. So we're going to start with the given. And then for hours to seconds, I don't know what that is off the top of my head. 3,600. But I do know that there are 60 minutes in an hour and 60 seconds in a minute. So what I can do is use multiple conversion factors to get from hour to second. It may take a little bit longer, but that's okay. Now, if you do know the hours to second off the top of your head, obviously you could do it in one step, but let's just pretend we don't. Okay, so I have hour as my given. So in the bottom, I'm going to have to think about hours. So I'm going to go from hour to minute first. So I know in 1 hour, there are 60 minutes. Again, I put hour on the bottom so that it matches the diagonal and that hour can go away. Minute went on top. Now, minute is not what it asked for. It asked for second. So I'm not going to box that in. That's not finished. That's why I need that second step. So in the second step, we're going to go from minutes to seconds. So to get from minutes to seconds, again, diagonals match. So for minute to second, I know 1 minute is 60 seconds. So I'm going to put that 1 minute in the bottom, 60 seconds on top, minutes cancel, and I finally got the unit asked for, so I could stop there. Okay, so in the calculator, we're going to multiply the top, divide by the bottom. So I'm going to do 0.89 times 60, and then divided by 1, which I'm not going to do. So you get 3,204 seconds. Let's talk about what to do if it's a unit squared, because a lot of people don't know how to deal with this, and you will be dealing with squared units in physics. So just in case, you need to know how to take care of it. But the process is sort of the same. You start with a given. Think of your conversion factor, and remember centi is 100 of something. So I have centimeter in the top, so I will put the 100 centimeter in the bottom, and per meter on top. The problem is the diagonals are not matching right now. It's centimeters, and then the given was actually centimeters squared. So how do you take care of that? You're actually going to square the number and the unit. So 100 squared, centimeter squared. And then do the same for the top. I know 1 squared is still 1, but we just want to be in the habit of doing that. So I have 1 squared meter squared. Okay, now you can do your multiplication and division. So I would actually multiply by 1 squared, which you don't have to do, but then you would want to divide by 100 squared, not just 100. So we're going to do 190 divided by 100 squared. And you do get 0.019 meters squared. Okay, this last one was just to give you a word problem. If you are traveling at 65 miles per hour, how many feet will you be traveling in 1 second? And then I do give you that 1 mile is 5,280 feet, just because that's not a common conversion. Now, the reason I chose this word problem is because it does say miles per hour, and you need to know that per is actually a fraction. So 65 miles per hour is how it should be written. We've already done one with a fraction. Like I said on the previous example, when you're dealing with units in a fraction, you can deal with the top first or the bottom first, and it does not matter. Since we did the top first last time, let's do the bottom first. So I'll take care of hours. It does want to know how many feet per second. So for hours, let's go from minutes to seconds, just to make sure you can do multi-step conversion. So let's go from hours to minutes, and then I'll go from minute to second. So if hours on bottom, diagonally, I would want to put the hour. So 1 hour is 60 minutes. That gets rid of hour. We're left with minutes, but that's not what I need. I need seconds, so I'm not going to circle that. I'm going to keep going. And then minutes is on bottom. So diagonally, I want to put minutes on top. 1 minute 60 seconds. Minutes cancel, seconds is left in the bottom, and I'll circle that because that is what I need. Now, the last issue is we still have miles. If you look back at the very beginning, we have 65 miles. We need to change that to feet. So I'll need one more. And luckily it did give me the conversion right there. So I do know that 1 mile is 5,280 feet. Now, miles is in the top. So if I go diagonal all the way across, I will want to put the 1 mile in the bottom. So it matches and it cancels. And that means the 5,280 feet would go in the top. Okay, so a lot to type in. Go across the top, do your multiplication, then go across the bottom and do your division. 65 times 1 times 1 times 5,280. Divide by 60, divide by 60. And we got 95.33 feet per second. Okay. So that's it for unit conversions. Again, you want to start with the given, make sure your diagonals match, cancel the units as you go. When you get the right unit, go ahead and circle it. And then you're going to want to multiply across the top, divide by the bottom, and get that final answer.